Y'all ready? Yeah. Cool. Okay. So 1.4 talks about the intersection of straight lines. And what I'm going to do is show you a couple different techniques to find where two lines intersect. We're going to play with a bunch of those examples, and then what we're going to do is we're going to do some word problems involving them. Sound like a plan? Cool. Now, before I begin, let me say something to you. Here are two straight lines. Do you guys agree this is where they intersect? Okay? Now, what does it mean that they intersect there? Well, they intersect at an ordered pair, x, y. That ordered pair lies on both of my lines. Do you all agree with me? Okay? So what we're wanting to do when we find where two lines meet is we're wanting to find the ordered pair that lies on both of those lines, or alternatively satisfies both of those linear equations at the same time. Okay? So we can have two lines intersect, and do you agree we get one unique solution? Now, I think that also, you guys watch it. We could also have two straight lines that look like that. Those are parallel lines. Do those guys ever intersect? No, these guys don't ever intersect. We're not going to encounter this today, but we will encounter this Wednesday or Friday. All right? So, if you want to know the point where these two lines meet, I think you'll grant me that saying no solution is a pretty good response. Okay? Now, your book eventually uses a word called inconsistent instead of no solution. Really, I don't care which way you put it. Now, a third type of situation that we could be in is we could actually have them be the same line. Now, I know you're like, okay, Lauren, wouldn't I see if a line was written the same way twice? There's ways to get it past you, okay? So just bear with me here. But if we asked, where do these lines intersect? Will you guys grant me that they intersect absolutely everywhere? Therefore, there's infinitely many solutions. Your book has a phrase that they call these dependent. Okay? All we are going to deal with today is finding where they cross. Okay? Now, there's actually three different techniques that we can use to find where lines intersect. The first one I'm going to mention to you is one that we're not going to go over in class, but you can always do this on your own if you would like to. It's called the graphical method. In other words, graph both lines and look and see where they meet. Okay? Now, if they meet at a nice ordered pair like 1, 3, life is really great because we can usually read that off of a graph pretty well. Okay? But if they intersect at some funky values like 14/3, negative 1/17, you're not going to be able to read that off of a graph very well. Okay? So we need other techniques. These other techniques are called the substitution method, and then there's also one called the addition or the elimination method. Okay? I will show you both of those methods. Now, on a test or a quiz, I won't tell you which method I want you to use. I'll say solve using the substitution or the elimination method. I want you guys to do what jives best with your brain. Okay? Let me show you both of these methods, and I'll talk about the various pros and cons involved in each. Sound like a plan? Didn't you miss this last week, you guys? Wake up every morning and down. I'll write my rules over there, and we'll just work through these. So, what if I have 4x plus y equals -7, and -5x minus y equals 10? And what I want to do is find where these lines intersect. Okay? Now, the first technique I'm going to show you is the addition or the elimination method. So let's do it. Okay? Now, if it is not already in the form that I have it written in, you want to get it in that form. In other words, you want your x and y's on one side and your constants on the other. Okay? We can easily move things from one side of an equation to the other. Yes? Okay. So, the first thing you want to do once it's taken the appropriate form is determine which variable you want to eliminate. Now, in some situations, it is going to be so obvious which variable you'll eliminate. Some situations, it doesn't really matter. Really, it doesn't matter which variable you choose to eliminate in general, just the issue is sometimes one way is more work than the other way. And I always opt for the least amount of work. Okay? So, how do you determine which variable to get rid of? Well, the key word here is additive inverses. If you don't remember what additive inverses are, you will. 5 and -5 are additive inverses. Why? Because, do you guys agree when you add them together you get 0? 12 and -12, 3 and -3, etc. Okay? So, the key thing here is additive inverses, because what we want to do is we want to add our two equations together and have the coefficients, in other words, the numbers in front of one of your variables be additive inverses of the other, of each other. Okay? Now, for example, I look at this guy and I see a 4 and a -5. Well, if I wanted to get rid of my x's, what I would do is I would ask myself, what do both 4 and 5 go into? And you would all tell me 20. So do you guys agree if I had a positive 20 here and a -20 here, if I added these two equations together, my x's would cancel? Okay? The thing is, I already have additive inverses with my y's, don't I? You see how I have a +1 and a -1? Okay? So, what you want to do is you want additive inverses because in the next step, you're going to add your equations together. Okay? So, my next step is, if necessary, multiply one or both equations by non-zero numbers to get additive inverses. Do you see how we already have that with our y's? So we don't really need to do anything. Okay? My next example, trust me, we won't have that. So, my third step then is to add my two equations. Let's do that. What is 4x and -5x equal to? -1x. What is y and -y? Cancel off, see you later. And what is -7 plus 10? 3. Well, if -x is equal to 3, will you guys grant me then x is -3? Okay? Don't worry, you guys, if this is funky for you, this is what we're going to be doing today. We got a lot of examples. So my step 4 then is to substitute value from step 3 into either equation to get the other variable. So, to follow through with that, if x is equal to -3, I need to find my corresponding y value. What I will do is I will take x equals -3, and I can plug it in either one of my original equations to get my corresponding y value. Okay? I'm just going to plug it in my top one just because why not? 4 times -3 plus y equals -7. You see what I did here? Well, 4 times -3 is -12 plus y is -7. Can I solve for y? You bet. Add 12 to both sides. Don't I get y is 5? So my solution is -3, 5. Now I claim you can check your answer, right? If you plug -3 in for x and 5 in for y here, you should get equality. If you plug -3 in for x and 5 in for y here, you should also get equality. You guys okay with this example? If this is weird, be patient. Let's do another one, okay? All right, so let's take this example. What if I have 2x plus 4y equals 11, -5x plus 3y equals 5? All right, remember my first step is to determine which variable we want to get rid of, okay? It's kind of sixes here, not literally, figuratively, in the sense that either way, we're going to have to do a little bit of razzmatazz in order to get additive inverses, okay? So if you walked up here and you said, well, I want to get rid of my x's, well, what do both 2 and 5 go into? 10. So do you agree I would have to multiply my top equation by 5 and my bottom equation by 2? You with me there? That's if I wanted to get rid of my x's. Now, suppose on the other hand I said, I want to get rid of my y's. Then I would look over at my y's and I would say, well, what do both 4 and 3 go into? 12. So do you agree I have to multiply one of my equations by 3 and the other one by 4? And one of them would have to be a negative? Okay? So, it doesn't matter. So let's just pick a variable. Who do you want to get rid of? X? Me too. Do you want to know why I wanted to get rid of x? Probably not, but I'll tell you anyways. The reason why is I already have a negative and a positive. Really not a very significant thing. Okay? So, do you guys agree I can take my top equation and multiply it by 5 and my bottom equation and multiply it by 2? Remember, it's legal to multiply an equation by something as long as you multiply every term by that number. So do you agree then I have 10x plus 20y equals 55 for my top equation? My bottom equation becomes -10x plus 6y equals 10. Any questions this far? Have you guys seen this before? So, my next step now is to add these together. What is 10x and -10x? 0, that was the plan. What is 20y plus 6y? 26y, and 55 and 10 is 65. Questions this far? Divide both sides by 26. Now, if you're thinking, ew, okay, that's okay. But actually, 65 over 26 is 2.5, so it's not as bad as it seems. So you get y is 65 over 26. If you wanted to leave it like that, fine. If you want to write it as 5/2, that's fine. If you want to write it as 2.5, that's fine. Who cares? They're all equivalent. Guys with me there? All right, I have my y value. I need to find my corresponding x value. How do we find our corresponding x value? We take this value of y and we plug it in either one of our original equations. Again, it doesn't matter which one you plug it in. Yes? You could plug it into the bottom ones. Also, your numbers will be a little bit bigger. But absolutely, that's a great question. Okay? I'll just plug it in my top one just because. So, 2x plus 4 times, would you guys be writing this as 2.5 or 5x? 2.5. I write it as 5x, but I'm going to do it like you guys do. I love practice. All right. So this actually turns out really nice because 4 times 2.5 is 10. Can we solve this for x? Totally. Subtract 10 from both sides, so you get 2x is 1, so x is 1/2. So using decimals, this would be your solution. Are you having fun? I can tell. All right. Are there questions? So, let me show you an example of the other method. The other method is called the substitution method. Again, I won't tell you which of these two methods to use. I want you to use one of these two, okay? So, the substitution method, I think, is a nifty way to solve these things, but it's really only reasonable to use when you're in one certain sort of situation. Okay, it's the most reasonable to use. Otherwise, it gets really messy. When the coefficient of one of the variables is 1. Coefficient, you guys, the number in front. You really only want to use this if you start out by having a 1 in front of one of your variables. Otherwise, you have fractions galore. Okay? Let me show you how you would use this. Now, one of the things I'll do is I'm going to write down another system. For practice, you can take this system and solve it using the addition or elimination method, and you'll see that we get the same thing that we got here, or that we will be about to get here when we use our substitution method. And don't worry, I'll write out the steps. So y equals 2/3 x minus 4, and x plus 3y plus 3 equals 0. Actually, hopefully you have a pencil. There we go. Let's start it out like this. Now, if you were going to use the addition or elimination method, the first thing you would have to do is scoot your constant to the other side, okay, to get it in that appropriate form, okay? But we're going to use the substitution method here. Now, why would I be willing to use the substitution method? I'd be willing to use the substitution method because notice in my top equation I have a 1 in front of my y. or alternatively, in my bottom equation, I have a 1 in front of my x. Okay? Those are the only situations where I would want to deal with it, because I really like that other method a lot. But here's how we do it. Once you decide to use the substitution method, solve one of the equations for one of the variables. So, doing that second step, I'm just going to take my first equation and get y all by itself. Okay? If I wanted to solve my second equation for one of my variables, I would scoot my 3y and 3 over and say x is negative 3y minus 3. You guys with me here? Okay, so that is my step 1. My step 2 then is to substitute that value into the other equation and then solve. So what do I mean by that? Well, do you guys see y is equal to 2/3 x plus 4? That's what y has to be. So what I'm going to do is take this value for y and plug it into my other equation. You guys agree I'm going to have x plus 3, but in place of y, don't I have y must be 2/3 x plus 4? Do you see what I did here? I tried to color code it. Are there questions this far? Okay, now what our next step is to do some algebra. I have an x. Don't I need to distribute my 3 throughout my parentheses? Sure do. What is 3 times 2/3? 2. So don't I get 2x here? And 4 times 3 is 12, plus another 3 equals 0. Can I solve this? Yeah, this is pretty sweet looking, right? 3x. I meant to have minus 4. We'll see how this comes out. So 3x plus 15 equals 0. So 3x is negative 15. So what is x equal to? Negative 5. Now, my next step is to use my solution in number 2 to solve for the other variable. It's too bad I made a typo. The answer's not. All right. So, you guys, we have x equaling negative 5. Don't we need to find our corresponding y value? How would we do that? Well, we would take x equals negative 5 and plug it in any one of these top versions. I would just plug it into here where it's already solved for y, just because for me that's the least amount of complications. So 2/3 times negative 5 plus 4. Is this yucky? A little. So don't you get negative 10/3 plus 4? Can we solve this? Right? 2/3 times negative 5. You guys all okay with multiplying fractions? Hello? Anybody there? Okay. What do you need in order to add two fractions? Common denominator. You get negative 10/3. Isn't 4 the same as 12/3? So we get 2/3. All right. Ready to play a little more? All right. So you may or may not remember, well, Okay? I have two more word problems I would like to do here. Okay? In section 1.3, we were talking about cost, profit, and revenue. Okay? And I brought up a concept called breaking even. You guys remember that? So when you have a business and you break even, doesn't that mean that you didn't lose or gain anything? In other words, isn't your profit equal to zero? Okay, that was one way we looked at breaking even. Breaking even, one way we looked at it was our profit was zero. Another way we looked at it is it's precisely when the costs are equal to your revenue. Okay? So, I'm doing this guy just kind of as a refresher for you guys from 1.3 also. What I want us to do is I want us right now to find the break-even point for a company whose cost function is 150x plus 20,000 and whose revenue function is 270x. Now, just to refresh your memories, I'm going to talk a little bit about what each of these values mean, because we did talk about what each of these numbers mean in terms of the cost and the revenue. So let's talk about our revenue first. Remember, the revenue, when we're dealing with linear functions, isn't it just the price we charge per item times the number of items sold? So, how much do we charge per item in this situation, you guys? $270. You with me there? Now, our cost function, remember when we're dealing with a linear cost function, our slope represented something and our y-intercept represented something, okay? In case you don't remember, our y-intercept represented our fixed costs. So what were our fixed costs here? $20,000. And what is this 150 here mean? Isn't that our production cost per unit? In other words, to produce each unit, it would cost us $150. Okay? If you don't remember this from the Friday before break or you weren't here, it's all in your textbook. So, what we want to do here is we want to find our break-even point. Well, we could do that one of two ways. We could do that either by setting our profit equal to zero or by setting our costs equal to our revenue. Well, since we have our costs and our revenue, why don't we just use this method? Okay? Do you guys remember how to get your profit from these guys? What is it? Isn't it your revenue minus your cost? Right? Think about it this way. How do you figure out how much profit you make? You take all the money that you earn, subtract off what your costs were, and hope for a positive number. Yeah? All right. So, to find our break-even point here, what I would do is I would set my costs equal to my revenue. All right. If I do that, how would I solve for x? Don't you want all your terms with x on one side and all your numbers on the other side? So I would subtract 150x from both sides. So do you agree I have 120x equals 20,000? Okay, how do you get x all by his lonesome? Divide both sides by 120, and I believe you get 166.6 repeating. I claim I have not answered the question, though. Okay? I want to know a value of x. What does x represent? Is this dollars? No, this isn't dollars. Isn't this the number of units? Yes. So, what would have to be our answer here? 166. Why would we have to round up? Because 166 wasn't enough. Okay? So you always round up in those situations. In other words, if we produce and sell 167 items, we'll break even. Anything less than that will lose, anything more than that will win. You guys with me here? All right, so one more example that I want to do with you guys is this. Do you guys like this stuff? Better or worse than probability? Some people better, some people worse, yeah. I love this stuff, but, you know, it's algebra, so it's fun. All right, so suppose you're about to move, okay? And you need to rent a truck in order to move your stuff, okay? And there's two companies in town. And you want to figure out which would be the cheaper company to go with. I mean, correct? That's a reasonable question to ask ourselves. Now, a lot of places where you can rent moving trucks from give you a basic charge for having the truck for the day, and then they also charge you per mile. You all agree with me? I don't know if you guys have moved much, but trust me, this is how it works. I've moved enough. So, suppose there's two companies in town. So company A charges 50 cents per mile, and they also charge 25 bucks per day. So just for having that truck and saying, oh wow, I rented this truck, and not driving it anywhere, it's going to cost you 25 bucks. You guys all agree that's a fixed cost? Yeah. Okay. And suppose there's company B. They only charge $20 per day, but they also charge 60 cents per mile. Now clearly, depending upon how many miles you want to move, in some situations you might want to go with company A, and in other situations you might want to go with company B. I mean, relative advantage, disadvantage. Just by looking at this, do you agree if you're not going to be driving very much, company B is better to go with? Okay, why? Because they have a less charge just for their base. But if you're going to be driving a ton of miles, well, this one might not be very beneficial for you beyond a certain point. So, what I would like to do is I would like us to find the cost function, renting from company A and renting from company B, and then figure out which would be the more optimal route to go in various situations. Doesn't that sound exciting? Well, I think it sounds thrilling, and then the next thing we'll do is probably even more thrilling. Then we'll be done with class. Is that exciting to you guys? At least I got a reaction. Okay, so for company A, I claim we can write this as a linear cost function. Totally we can. Okay? What is my slope here? 50 cents per mile, isn't it? Okay? So the way I would write that is 0.5s, because I want to write this all in terms of dollars, plus 25. You all see how I got this cost function from my first scenario, right? If I drive 0 miles, in other words, this thing's 0, it's still going to cost me 25 bucks. If I drive 1 mile, it's going to cost me $25.50, etc. You guys with me here? So this is essentially our variable costs, and these are our fixed costs. Okay? For company B, what's my cost function equal to? 0.6x plus what? 20. Are there any questions how I got those? Okay. So, the first question I'm going to ask ourselves go for the cost to be the same. In other words, where if I rent from company A or I rent from company B, it's going to cost me the same amount. Can we figure this out? How would we do this? Aren't we looking for the cost from company A to be equal to the cost from company B? You with me? So what is the cost from company A? Isn't that 0.5x plus 25? What's the cost from company B? 0.6x plus 20. Can we solve this? Totally. Move all your x's to one side. So don't I have 25 as 0.1x plus 20? So 0.1x is 5. So x is 50. So if we drive our truck exactly 50 miles, it doesn't matter who we rent it from. It's going to cost us the same thing. Okay? You guys with me here? So let me ask you guys another question then. If I'm driving less than 50 miles, who should I rent from? Company B. Okay, because the base cost is cheaper. If you're unsure of that, just take a number, like any number less than 50, like 30, and plug it into each of these guys and see what the cost would be. But I claim company B would be cheaper. If I'm driving more than 50 miles, I claim we should then go with company A. If you're unsure of that, take any number greater than 50, take 90. And if you drive 90 miles, see what the cost would be with each company. I claim it would be a lot cheaper with company A. Are you guys with me? Okay? If you don't believe me, let's just take this and check it out. Okay? You guys want to see, like, okay, let's go 30 miles. How would we find how much company A costs with 30 miles? Well, would you take 0.5 times 30 plus 25? I claim it would be 40 bucks. With company B, you would take 0.6 times 30 plus 20. And what do you get there? $38. So we save $2 by going with that other company. Okay, you guys, this is not a stupid question in the sense that this is a very realistic thing to look at, especially when you're driving a boatload of miles, like moving across the country. Well,